Hello everyone, welcome back to our Python Complete Course series. My name is Sangam and this is day 4 of our Python journey. If you are new to this series, don't worry, I have created this course from absolute beginner level so anyone can learn Python even without any programming background. Before we start, make sure you have watched day 1, day 2 and day 3 because we have already covered many important concepts like variables, data type, input and outputs, operators, strings, indexing, slicing, string methods, and format, and f strings. And let me tell you something exciting. Today is the day where our Python programs become intelligent. Till now, whenever we wrote a Python program, it simply executed one line after another. It never asked questions, it never compared values, and it never made decisions. But think about our daily lives. If it is raining, we carry an umbrella. If our age is 18 or above, we can do vote absolutely. This question is, can we teach Python to do the same? Absolutely. In today's class, we are going to learn conditional statement in Python. We will cover if else, elif, nested if, logical operators, comparison operators. We will build some amazing beginner friendly projects like a calculator program, marks checker, voting eligibility program, and BMI checker. By the end of this 1 hour video, you will be able to write program that can think, analyze, and take actions based on different situations. So grab your notebook, open VS Code, and get ready to take your Python skills to the next level. Let's start day 4 of the Python complete series. Let's go to computer screen and start the day 4. This is day 4 of the series, and I hope all of you completed yesterday homework. Before starting today's topic, let's quickly revise what we learned in day 3. Yesterday, we learned about strings in Python. We understand that a string is simply a sequence of characters enclosed in quotes. We learned string indexing, where we can access individual characters using their positions. For example, I write name equal to Sangam, and the first line print the S only. Then we use string methods like upper, lower, capitalize, and many more. In this example, upper converts the entire string into uppercase letters, and after that, we learn negative indexing, string slicing, the format method, and finally F strings, which are the modern and recommended way to format string in Python. If you have not watched day 3 yet, I highly recommend you watch it before continuing because today's topic builds on the concept of variables in input and strings. Up until now, all our Python programs have been executing line by line from top to bottom. They never asked questions and they never made decisions. But think about real life for a moment. If it is raining, we take an umbrella. If we score above 90 marks, we feel happy. Humans make decisions every single day. So the question is, can our Python program can make decisions too? The answer is yes. Starting today, we are going to make our Python program intelligent by teaching them how to think and make decisions using conditional statements. By the end of this video, you will be able to create programs like marks checker, voting eligibility program, calculator, and even a BMI checker. So without wasting any more time, let's begin our journey into conditional statements in Python. I write here today's topic, conditional statement in Python. All right, everyone, now let's begin with our first topic of the day. Before I explain the definition, let me ask you a few simple questions. If it start raining outside, what will you do? Most of you will say, I will take an umbrella now. Suppose your exam results are announced and you score more than 90 marks. What happened? You will probably celebrate, tell your parents, and maybe even get a treat. And here's another question. If your age is greater than or equal to 18, can you vote in India? Yes, absolutely. Did you notice something common in all of this example? In every situation, there is a condition. If the condition is true, we perform an action. If the condition is false, we do something else or do nothing. This is exactly what conditional statements I write here, the notes of the conditional statement. If the condition is true, we perform an action. If the condition is false, we do something else or do nothing. You can think of conditional statements as a way of teaching Python how to make decisions. The definition is very simple. Conditional statements are used to make decisions in Python and based on whether a condition is true or false. Now let's look at the basic syntax of a conditional statement. Like I show here, syntax of conditional statement. If condition and code. This is basic syntax of conditional statement. First we write the code if. First, then we write a condition. The condition can be anything. That result is either true or false. After the condition, we put a colon, and the code written inside if block will execute only when the condition is true. If the condition is false, Python simply skips that blocks of code, move to the next line. Let's understand this with some real life example. Example number one. If the battery percentage is less than 20, we charge our phone. Example number two. If the password entered is correct, the user is allowed to log in. Yes. Example number three. If the temperature is greater than 40 degrees, we turn on the air conditioner. So everywhere around us, conditions exist. And from today onwards, our Python program will also start making decisions just like humans. In the next session, we are going to learn our first conditional statement in Python, the if statement, and we will write our very first decision making program. Now that we understand what conditional statements are, let's learn our very first conditional statement in Python, the if statement. The if statement is the simplest way to make decisions in Python. Its job is very straightforward. It checks whether a condition is true or false. If a condition is true, Python executes the code inside the if block. If the condition is false, Python ignores the code and continues with the rest of the program. Let's see our first example. Like here I write age equal to 20. If age is greater than 18, print you can vote. If I run this code, it prints you can vote. Fi- Let's understand this line by line. First, we create a variable age, store the value 20 in it, and that write if statement and ask Python a question: is age greater than equal to 18? In your case, in our case, age is equal to 20. So Python checks is greater than 20 is greater than 18. The answer is yes, which means the condition is true. Since the condition is true, Python executes the code inside the if block and prints you can vote. Now let's change the value of age from 20 to 15. If I write here 15, no, here 18, here 15. If I run this code, this time answer is no. Since the condition is false, Python skips the print statement completely. Notice something very important here. Python does not give an error. It simply ignores the code inside the if block. This is how the if statement works. Let's take another example. Here, again, Python asks, is 95 is greater than 90? Yes, so it prints excellent. Now I have a challenge for all of you. Pause the video for 5 seconds and think about this question. What will happen if I change the value of marks from 95 to 80? If you answered that nothing will be printed, congratulations, you are absolutely right. Because Python checks is 80 greater than 90? No. And when the condition becomes false, the code inside the if block is skipped. This is the beauty of a statement. It allows our program to perform actions only when certain conditions are satisfied. Before moving on, remember this one line. The if statement executes code only when the condition is true. Keep this in mind because every other conditional statement in Python is built upon this process. Now that you have understood the if statement, let's move the next topic, if else. Let's make our p- program even smarter. Think about this for a moment. Suppose I ask you, is a number even? There are only two possibilities. Either the number is even or it is odd. Similarly, if I ask whether someone is eligible to vote, there's only two answers, yes or no. This is where the if else statement comes into the picture. The if statement only tells the Python what to do when the condition is true, but if the condition is false, that's exactly why we use else. You can remember it like this. If true block, else false block. Let's see the syntax. I write here the theory. If condition runs if condition is true and else condition run if condition is false. Now let's write a interesting program to check whether a number is even or odd. I already write here the number is even or odd. When I run this code, enter number. I write here 20 and enter. It gives even. In this code, first we ask the user to enter a number, then we use the modulo operator. Remember from day 2. The modulo operator gives us the remainder. If a number is divided by 2 and the remainder is 0, the number is even. Otherwise, suppose the number I uses user enters 20. Python checks 10 modulo 2 equal to 0. Yes. So Python enters if block and prints even. Now suppose the user enters 7. I write here 7. And when I enter, Python asks, is 7 modulo 2 equal to 0? No. Since the condition is false, Python skips the if block and executes the else block printing odd. You can visualize it like this condition, then true, if block, false, else block. This is how Python decides between two possible outcomes. Let's practice with another example. I already write it here. Just comment out this and comment in this. Pause the video and think for a second. Will Python print adult or minor? Since 16 is less than 18, the condition becomes false. Therefore, Python execute else block, prints minor. Congratulations, you know how to handle both true and false situations using the if else statement. But what if we have more than two conditions? That's exactly what we are going to learn next. Until now, our program had only two choices. For example, yes, no, even, odd, adult, minor. But in real life is not always limited to just two options. Let's take marks as an example. A student get A plus, A, B, or fail. Now tell we can we handle four possibilities using only if and else? No. And that's why Python gives us another keyword called elif. Elif stand for else if. I write this on notes. It allows us to check multiple conditions one after another. Let's write a grading program. Let's understand the flow of this program. If marks are 90 or above, print A plus. If marks are 75 or above, print A. Else if marks are 60 or above, print B. Otherwise, print fail. Now let's see what happens when marks is equal to 82. Python starts from top. First it checks is 82 is greater than or equal to 90. No. Then it moves to the next condition. Is 82 is greater than or equal to 75? Yes. The moment Python finds a true condition, it executes that block and stops checking the remaining conditions. This is very important to remember. Python always checks condition from top to bottom and stops at the first true condition. Now let's check have some fun. Question number one. What will happen if marks are 95? Take a moment or think. I write here 95. And when I run this code, it prints A plus. The question number two. What if I write here marks is equal to 65? Then uh, Python prints B. And finally, what happens if marks are 30? Since none of the conditions are true, Python reaches the else block and print fail. So remember this rule. 90 plus equal to A plus, 75 plus, 75 plus A, 60 plus B, anything else fail. And with that, you have learned one of the most useful concept in Python, handling multiple conditions using elif. In the next section, we will learn nested if statements, where we can place one condition inside another and create even more powerful programs. Awesome. So far we have learned if is and else statements. Now it's time to learn another interesting concept called nested if. The word nested if simply means something placed inside something else. I already write here that in note section nested if means one if inside another if. For example, think about a gift box. You open a box and inside it you find another box. Similarly, in Python, we can place one if statement inside another if statement. This is known as nested if statements. In simple word, a nested if is an if statement inside another if statement. Let's understand why we need it. Imagine you are trying to enter a concert. The security guard asks, "Are you 18 year or older?" If the answer is no, you cannot enter. But if the answer is yes, the guard asks another question. Do you have an ID card? Only if both conditions are satisfied are you allowed to enter. Let's write a Python program for this situation. I already written here age equal to 20, ID card equal to true. If age is greater than equal to 18, if ID card present, then print allowed, else print bring ID card, and if it age is not greater than 18, then print not eligible. Let's execute this program step by step. Python starts with the first condition. Is age greater than or equal to 18? In our case, age is 20, so the answer is yes, since the first condition is true. Python movies inside the first if block. Move inside the first if block. Now, Python checks the second condition. Does the person have an ID card? The value of ID card is true. Therefore, Python prints entry allowed. When I run this code, entry allowed printed. Now let's change ID card to false. And I change here ID card to false. This time the condition is still true because the age is 20, but the second condition false, become false. So Python executes the else block inside the nested if and prints bring ID. When I run this code, it will print bring ID. And finally, let's change the age to 15. Now Python checks if 15 greater than equal to 18, no, since the first condition itself is false. Python never checks the ID card condition and directly prints not eligible. You can visualize the entire flow like this. First Python check is I write this on notes. This is entire condition and workflow of this. The concept is extremely useful in real world applications. For example, ATM machines first check whether the ATM card is valid and then they ask for the PIN. Website first check the username and then verify the password. Traffic police first check your age and then ask for your driving license. Online exams first verify your registration and then your identity. So whatever one condition depends on another condition. Nested if statements are the perfect choice. Remember this one line. Nested if means placing one if statement inside another if statement. Congratulations. You know, you now know all the major conditional statements in Python. In the next section, we will learn comparison operators and logical operators, which are the building blocks behind all these conditions. Now that we have learned how to use if else, elif, and nested if, let's talk something very important. Have you ever wondered how Python decides whether a condition is true or false? For example, how does Python know that 20 is greater than 18 and how does it know 10 is equal to 10? The answer is comparison operators. The comparison operators are special symbols used to compare two values. And remember this very important line. Conditions are built using comparison operators. Without comparison operators, we cannot write conditions in Python. Let's look at all the comparison operators one by one. I already written here. Let's understand each one with examples. The first operator is double equal to. Now carefully, it uses two equal signs. Many beginners make the mistake of writing only one equal sign. Remember, what one equal to signs means I already talk in first or second day. One equal to signs means assignment and double equal to signs means comparison. Let's write some examples. Print 10 is greater than 5, print 10 double equal to 10, and print 5 not equal to 10. Let's run this code and see the output. In the first line, Python checks is 10 greater than 5. The answer is true. So Python prints true. In the second line, is 10 equal to 10. Again, the answer is true. So Python prints true. And finally, 5 not equal to 10 since both values are different. Python prints true once again. Now let's try run this code. These are the answers. Let's try a few more examples. I am giving a question. 10 less than equal to 5. Print 10 less than equal to 5. Print 20 greater than equal to 20. Print 15 less than equal to 10. Let's predict the output together. Is 10 less than 5? No, so the output is false. Is 20 greater than or equal to 20? Yes, so the output is true. Is 15 less than or equal to 10? No. So the output is false. When I run this code, it will print false, true, false. Notice something interesting. Comparison operators always return either true or false. There is no third option. And these true and false values are exactly what our conditional statements use to make decisions. For example, I am giving you example. A is equal to 20 if A is equal to greater than 18, print eligible. Here, age is greater than equal to 18 is a comparison. Python evaluates it as true, and that's why the if block executes. So whatever you see a condition in Python, look carefully. You will almost always find a comparison operator behind it. Remember these six operators because you will use them in almost every Python program you write from now on. These are the six operators: double equal to, for equal, not equal to, greater than, less than, greater than equal to, less than equal to. Conditions are built using comparison operators, most importantly. In the next section, we will learn logical operators, where we will combine multiple conditions together and make our program even more powerful. Excellent. We have learned how to compare values using comparison operators. But what if we want to check more than one condition at the same time? For example, a person must be 18-year-old and have an ID card. A user can log in using an email or a phone number. We want to reverse the result of a condition. This is where logical operators come into the picture. Logical operators help us combine multiple conditions together. Python provides three logical operators: and, or, not. Let's understand them one by one. First, let's see some simple examples. I already written here. Let's execute this code. The first statement is true and true. The AND operator returns the true only when both conditions are true. So the output is true. The second statement is true or false. The OR operator returns true if at least one condition is true. Since one of them is true, the output is also true. And finally, not true. The not operator simply reverses the answer. So not true becomes false. Very simple. Now let's understand each operator in detail. The AND operator. The AND operator is very strict. It says I will return true only if all conditions are true. Let's see an example. A is equal to 20 has ID card equal to true. If age is greater than equal to 18 and has ID, when I run this code, it's Python first check is age greater than equal to 18, yes. Then it says does the Python person have an ID card, yes. Since both conditions are true, Python prints true. But if one condition become false, the entire result become false. You can remember it like this. This I write in notes. True and true equal to true, true and false equal to false, false and true equal to false, and false and false equal to false. A real life example of an ad: age plus ID card, ATM card plus PIN, username plus password. All conditions must be satisfied. Now let's move to the OR operator. The OR operator is more flexible. It says I will return true if at least one condition is true. Let's see an example. Print false or true. Since one value is true, the output will be true. Think about logging into a website. Sometimes it says continue with email or phone number. You don't need both. Any one option is enough. Other examples include pay using UPI or debit card, login with Google or GitHub, contact via email or phone. Finally, let's learn about the NOT operator. The NOT operator simply reverses the result. Let's write this. Print not false. What do you think the output will be? That's right. Print true. Because not changes true to false, false to true. You can think of not as a switch that flips the answer. For example, door is open, not open means closed. User is logged in, not logged in means logged out. So let's quickly revise. And all conditions must be true, and not at least one condition must be true, and not. Reverse the answer. Logical operators are extremely useful and are used everywhere in programming. And now that we have mastered all the theory behind conditions, it's time for the fun part. In the next session, we will start building our first mini projects, beginning with a calculator program.